Hi everybody, it's Tyler here at the Highlander Subnet Signature event. Check in 88898. It's 99%. We're happy to check in with them. Once again, phenomenal season last year. Also division finalists at Worlds as well too, so congrats on that. And bringing another great robot as we're filming late here at Highlander. 99% this year, all about just compactness for it, able to go low underneath and scoring just super fast. So we're going to detail more of their design that they have so far, a little bit about programming and how they're utilizing that, and also a pretty dope controller that they have as well that we'll dive a little bit more into coming up here on Fits and Parts. Charles, let's dive right into this robot here. Talk to me more about the overall design. How did you approach, this game coming into Highlander so far?
Yeah, so I think so for the overall design, we wanted to go from like a front intake to a front scoring because that's the easiest way to drive personally. So that's why we went with this snail or the C design, and yeah. So the thing that's special about our C design is the top part is actually pistonized. So we can release the air and it goes down under the bar, and it's very compact. Yeah. And overall, this bot is only around 12.75 pounds.
What design challenges did you have trying to build like a compact low bot?
Yeah, I think the biggest thing is getting the geometry right. So as you can see here, let me just raise it with the you can see that the top part moves. So we have to make sure that at all times there's no dead zones in the intake, so the balls don't get stuck anywhere. So there's just a lot of tuning with like just flex wheels and like the roller placements.
Can we see a couple blocks come in, just see how that process works for your team? So how many are you holding max capacity?
Yeah, so we're holding like 6-7 balls. Yeah, so yeah.
So when you look at like 6 or 7, what made you to, settle on that amount? Was it just based on the design limitations they had on the compactness, or did you want maybe to go up to like 8 or 9 at all?
Yeah, so I think we're just really focused on quick cycles right now, and especially since the match loaders only hold 6 balls, after Auton we can get 6 balls extremely quickly and then go score.
Talk to me a little bit more about match strategy and how your team's been tackling so far during qualification matches. Are you seeing pretty much the same strategy played out most matches for your team, or is there some variance depending on the match?
Yeah, so I think definitely a very important part of this game is Auton, since it's a 20-point swing if you win or lose. And then definitely after Auton, we're going to try and focus on double teaming a goal so we can control one full long goal. And then we're going to have either us or Alliance go focus on the middle and low goals, because a lot of teams forget about those. But combined, those 2 goals still give around 40 points.
Obviously been very successful here so far as we're filming this at Highlander, but looking to the future, are there any other big design changes you have in mind that you might want to share at all?
Yeah, so a big problem is with the C-Bot where the front to front is autonomous. So it makes autonomous routines a lot harder because after you match load, you have to turn around 180 to go score, and that's just time limitation, and 15 seconds isn't a lot of time.
Your team has had great success over the last couple of years that you've been around so far. What do you think some of the key attributes as a team working together to be so successful? Can you share some tips for that?
Yeah, so definitely just organization. So over the past few years, we've been holding weekly meetings on Saturday just to keep everything on track. Make sure all the action items that we create are done. And another thing is definitely just experience. As you do Vex like longer and longer, things just become a lot easier, yeah.
Andrew, we talked about how important autonomous is for things. I'd love to hear more about some of the sensors that you're doing, anything from a programming aspect that you want to dive more into, and what's made your team so successful here on the field.
Okay, so there are 2 parts of the programming, 2 main parts. So there's the position tracking of the robot on the field, and then there's the actual movement of the robot on the field. And so for position tracking, you want to be able to track your robot in a coordinate, like X and Y coordinate on the field. So we have, if you look on the bottom of the robot actually, hey Charles, there's no odometry dead wheels, like most teams have. And so this is a lot more noisy if you're just using the motor encoders. And so to help with that, we have 4 distance sensors around the robot. You have 1 in the front and the back, and you have 1 each on the sides. And then, so since there's noise in the odometry, you can represent the position of the robot actually as a two-dimensional probability density function. And so a commonly used technique in robotics is to estimate the PDF using a Bayesian filter. So using the sensor, we can like use a Gaussian likelihood of the sensor. So like, let's say the robot is, we think it's, according to the odometry, it's 6 inches from the wall, but then the distance sensor actually reads 3 inches from the wall, right? Then the parts of the filter that are closer to the wall, it's gonna have a higher likelihood that the robot is there. And so by constantly iterating over this algorithm every single loop, then you can have a more accurate representation of the robot position.
So it's just constantly resetting that pose every single time, or that position that you have every single time for it. Gotcha.
Yeah, and then so for movement, we have 2D motion profiling with Ramset. So basically, it uses quadratic Bezier curves to calculate a path between different control points on the field. The robot can move in a continuous path from point A to point B. We can like add more points in between to have it follow a certain trajectory.
Are there any improvements that you want to make from a programming side, looking at future competitions for yourself?
Yeah, I mean the programming is kind of rushed this year, so
Yeah, I heard you had a couple late nights getting this out.
yeah, I'm on like maybe 3. I've had like a total of like 8 hours of sleep over the past 2 days. Yeah, I just think we just need to better tune the programming. One problem that we had with the robot is like for the distance sensors, you're comparing the expected value of the distance sensors with the actual value of the distance sensors, right? For the particle filtering, except like when you're near a match loader, right? It's like you can't. It's like hard to like, because like the wall, like it's gonna be an offset from like the wall, the distance sensor reading. So it's like hard to manage controlling that. And yeah, that's been the biggest issue with this.
Yeah, for sure. One thing I want to wrap up on too, I got to talk a little about your controller. Can you just talk about, it looks like a hydro dip that you did on that. Can you just give me a little bit more on the controller? And I love the color scheme of it. It's super cool.
Yeah, so pretty much a few weeks ago we decided to, we were kind of bored, so we decided to customize a controller. So pretty much we took the entire thing apart, stripped all the electronics out, so that way we were able to just spray paint the whole thing. And then the front is actually hydro dipped. You'll notice that all the buttons are pink as well. So we had some clearance issues, so we just had to make sure everything was filed so everything didn't stick.
99%. Thank you so much for taking time once again. Looking for another great year from your team. Obviously, I know you got high expectations of yourselves as well too. But can't wait to see how you continue to do. So good luck here at Highlander, and hopefully check in with you throughout the rest of the season. Thanks a lot.
Okay, thank you.